Hi, welcome to our sixth session. And today we're actually going to do two sessions. We're going to do Module 5, Interactive Triage, and Module 6, Proactive Hunting. So Module 5 is not very long, so we'll be able to finish that pretty quick. And then we'll dive into Proactive Hunting. And then hopefully at the end, we're going to talk about a little bit about the Elastic integration, and I have a small, demo for Elastic. But we're not going to talk about Elastic too much, right? It's just one little couple of slides. Okay, so let's dive straight in. Actually, before we start, does anyone have any questions from the previous sessions, or as usual, if you have any questions, just type them into the chat or the Q&A, and then I'll address them. Okay, so let's start off with the Module 5, Interactive Triage. And in this one, what we're doing in this module is essentially doing triage or DFIR work without a server. Now, so far we've seen, in the first module, we've seen how we can install Velociraptor as a server, and we've seen how we can scale it up with thousands of machines and thousands of endpoints and so on. But sometimes you can't do that because for whatever reason you can't actually install Velociraptor on endpoints, or you can't use Velociraptor in an instant response type scenario. So you might think, oh well, I wish I could use Velociraptor in this in this engagement or in this investigation, and actually you can, right? Because let's remember that Velociraptor is a VQL engine. So that's really all it is it runs VQL, and because it's essentially just an VQL interpreter. Now, of course, normally we have a client and server model that makes it very easy for us to collect new artifacts, to collect artifacts from endpoints and centrally manage it and create hunts and things like that. But at the end of the day, that is just the mechanics of running VQL on the endpoint. Really, all we need to do is just have Velociraptor evaluate the VQL on the endpoint. With that, it doesn't really need a client and server to actually operate. So sometimes we find that we don't have a way of actually installing a proper client server, and we need to rely on someone else to do the collection. So either it is another person, for example, like a remote field office or help desk or whatever, or if they have another DFIR agent or another EDR agent, then we can use that to deploy our. There's a question. Feel free to describe how this compares to CAPE functionality for collecting artifacts. So CAPE, we are going to talk a little bit about CAPE functionality, but CAPE is really all about collecting files. And Velociraptor is a full-blown VQL engine. So it's sort of similar in some ways, but Velociraptor allows you to run any artifact, right? Not just collect files. So as you've seen yesterday, we do a lot of the parsing on the endpoints, like for the event logs, and all of these things can be done in this way as well. So it's similar, but a little bit different. Does it have any support for KDR? I'm not sure what KDR is. Sorry. Okay, so so what we're going to do is essentially prepare Velociraptor for local interactive triage collection. Now, if any of you have ever been in a situation where you have to ask someone else to do the collection for you, especially someone who's not necessarily computer savvy or doesn't really feel comfortable around a command line, then you know that it's fraught with danger. And a lot of other tools, they have a command line you have to type, or maybe a script or some kind of interaction, and they require the other person to essentially, type that or whatever. And so what we actually want to try and do is we want to minimize this confusion. KPMG digital, I don't know what that is. So what we actually want to do is we want to use build a binary that is that's basically knows what it's doing without any interactive use from the user at the remote end, because they're probably not going to be able to type a complicated command line, especially if it's an EDR agent that you're just deploying and running. So you don't want to interact with it too much. Okay, so ultimately, Velociraptor is a VQL engine, and we know already that VQL queries are encapsulated inside an artifact, and we have parameters and other things like that. So all we really have to do is collect these artifacts, locally, right? So let's talk a little bit about collecting artifacts. There's just a quick question. Cape also has a .NET requirement, and Velociraptor has static libs. Yeah, that's right. So yeah, so Cape needs to have .NET, and Velociraptor doesn't. So it's a little bit easier to deploy. So let me just have a look at how we can collect artifacts. So we've already seen how we can collect artifacts, but what we're going to concentrate on this module is more endpoint state. So usually that means collecting files. So the idea here is to just collect a whole bunch of files and sort of like do sort of a forensic acquisition, but except that remote acquisition is not really practical. You're not going to be able to do a bitwise copy of your disk. So what we want to do is capture as many of the files that we normally have and just acquire them. And this is we've already discussed the difference between parsing things on the endpoint versus downloading the files and then parsing them on the server. And we've got to realize that when you're collecting files, we can't really do a lot of hunting. We can't scale that, right? But sometimes when we have a particular machine that we know is compromised, we just want to capture endpoint state. So that means we want to acquire those files and keep them, right? So really acquiring files, collecting files is really all about capturing and preserving the endpoint state. I wouldn't say it's really about investigating, when it's more about capturing it. Is it possible to schedule hunts? Yes, so we can talk about that. It is possible to schedule hunts using a VQL query, but there is actually an example of that in the wiki, I think, in the wiki. Okay, so let's go and start up our Velociraptor as we normally do, right? So we're just going to run Velociraptor Gui as we do, every day. Let's start it up, and I'm just going to show you the Cape files targets artifact, which has already been mentioned before by questions. And this is really an artifact that's designed to, it's still designed around a tool called Cape. So Cape is it's not a free tool, it's a commercial tool, but it has, essentially it's just a tool that's used to capture files, right? And it uses these things called Cape file target files, which are sort of like YAML files, which is a community shared resource of essentially, I wonder if I'll show you what it looks like. So GitHub Cape files. So there is this is the repository. And you can see that here, yes, you're right. So Cape can capture and process, but the processing side is usually not done on the endpoint. So it's the capturing side is usually done, but the processing side is essentially a bunch of these YAML files just shell out to external tools. So so these are just kind of like YAML files, and it tells the tool how to collect it. But the targets, so the modules are the processing part, but the targets are actually the collection side of it. And so you can see, they're just kind of split off into different names. So this one is combined logs, for instance, and that's called a target. And then here we have, just different paths. But essentially all of these YAML files essentially boil down to just glob expressions. So they're just big verbose kind of YAML files that give you a lot of context and stuff and dependencies and things like that. But in the end, they just end up being like a glob expression here, with wildcards and so on. So what I did was convert that entire repository to a set of glob expressions and then build an artifact based on that. So let's have a look at how that works. So again, we just collect a new artifact, click new collection, just search for the K files targets, and you can see that it's essentially it's a huge artifact because it's automatically generated from that repository, and it just basically has it's designed to just be easy to use more than so it just has a bunch of these flags. So if we just have a look at the parameters, we can use VSS, and then we've got these are called targets, but they're just shown as parameters, like they're just normal regular artifact parameters. Like there's nothing really special about it. Essentially, it's converted into VQL, but each of those is a target, and then we can choose it. Or you can see that that there's some targets, they include other targets, as dependencies. So when we select the basic collection, so if we click on that, then it will select all of these things, and you can see that it will fetch, recycler files, the strum, $J, all these things, and then registry hives and all this sort of stuff. So it's you can go and select them individually, or you can essentially click that and it will select all the dependencies. So it's just a quick way of doing that. But that's all it is, right? We just do this and off we go, right? And it's going to go and start fetching these files, which there's going to be a lot of them, right? And from the endpoint. And it's just figuring out what to fetch, and then it will start to see. So now we're starting to move the bytes. And you'll see that number, increases, and as it's, starting to retrieve files, and that byte count increases. So I mean, it's just an artifact. So it's basically the same as what we did. Remember in the second, the forensic analysis part 1, where we did this glob and upload. Remember, we did the glob and upload exercise. It's exactly the same, but all it is just a GUI like around that, right? Because we've just pre-programmed those globs into the artifact, so we can just click a button to fetch them. So if we look at the uploaded files, then these are that's the recycle bin and the boot file and other things, right? So they're just basically fetching all this data, and it's gonna basically move a lot of data, right? This is gonna be pretty big. So there is a limit, and just to kind of protect the server from downloading too much. But this is how we would do essentially acquisition, but it's not really acquisition. It's not complete acquisition, but it's just capturing as much of the state as possible. So, I mean, I would just generally try and do the analysis on the endpoint to identify the compromised endpoints, and then use the cap files to capture that. Question: are the built-in Velociraptor artifacts updated continuously, including new and modified cape targets? So, I mean, there is a script that we use to sync up the repository. I don't know how often we do that. I don't know. We do it like every release, but yeah, certainly you can do it at any time, right? And we probably should keep more up to date. Yeah. Can CAP acquisition be scheduled for multiple machines in a single go? I mean, it's just an artifact, right? So you can simply just, there's nothing stopping you from doing a hunt. It's just a terrible idea to do it on too many machines. So, you know, you can simply label a bunch of machines and then just do a hunt on them, right? I mean, that's okay, but except that you have to realize that you're probably moving like a couple of gigs of data, you know, for each one. I mean, we're already moving, I think that's 1.5 gigs, and it's still going, right? So there's just going to be a lot of data on any normal machine. You know, I mean, it's finished, right? So it's done about 1.3 gigs, right? So it's quite a lot. But this is a relatively clean machine, and so sometimes even the basic collection will be quite large. Can keep a position? Yeah. So this is basically, I guess what I'm trying to show you here is that this CAPE collection is really just about collecting files, and it's not actually analyzing them. So this is the user journal that we've seen before with this, you know, it's being sparse, and it's not really about analyzing it. It's just about collecting a bunch of files just for sort of acquisition, basically. And you can export it. You can create a download here, and it will export the files in a zip file. So it's building a zip file here, and then, you know, you can take a look at it or export it or whatever, right? So it's just files. But you can see that it's not really super scalable. I'm not going to be able to collect, you know, a couple of gigs from thousands of machines, right? It's just not going to scale. And I'm not going to be able to parse those offline, because now I have to parse those raw files, you know, in the same spot. So it's just not scalable, right? It's much better to parse and search for things on the endpoint. But, you know, but still, it's still kind of a useful feature, and, you know, a lot of people use it. So I'm showing it to you. And yeah, so they basically just go through and select the target, the correct checkbox here, and off it goes. Over here, you can see the progress, how many bytes were uploaded, and how long it took, right, to do this collection. As I said, we normally never do that in a hunt because it's just too much data. It's normally very targeted to just one machine or two machines or several machines. But yeah, just the thing to realize is, you know, if you're just going to collect 100 megs from 10,000 endpoints, like it's just you know, you're going to run out of this space. And we've seen this a lot, especially when, you know, people accidentally do, like, especially people who are doing DFIR work and are used to doing it on a small scale, and then they start to use Velociraptor, and they just continue using the same techniques that they use, you know, to analyze one or two machines, and, you know, and then they just try and sort of use the same techniques on, you know, 5,000 machines. Then suddenly, you know, they just basically fill the disk up, right? Because you know, if you're doing a SANS course or whatever, they'll teach you, you know, go grab the prefetch files and then analyze them and then look at them offline and then do this. So there's a process, right, that people are used to. But then if you try and do the same thing in Velociraptor, just because of math, it's just not going to work, right? If you're trying to grab the MFT, you know, from usually it's MFT is at least 300 or 400 megs, and if you're just doing a hunt to grab the MFT, then you're going to use up 3 or 4 terabytes without. And because Velociraptor is really fast, you know, you're going to, if you just kick that off, you know, within 2 hours, you've discovered that you've pulled like 4 terabytes, you know, without any problems. It's just going to pull as fast as possible and just fill the disk up. So this was the source of a lot of accidents, you know, that happened, right, because of this. And so we ended up putting in a lot of resource controls to try and control these accidents, to try and make sure that they don't happen. So there are limitations in Velociraptor to try and make sure that we don't have these problems. So the first limitation is offs per second. That's mostly used for ERS scanning, so that we don't want to run full speed on the endpoint, right? So we want to not run slowly. For scanning, like Yara scanning, then it doesn't really matter how fast you go as long as you go at, at the reasonable rate. So in that case, we can use this setting to go a little bit slower, so we can scan a little bit slower, and then we are much lighter on the endpoint in terms of CPU usage and I/O bandwidth. And then we have this second limitation, which is the maximum time that any query can take, and that's 10 minutes by default. So if we run in any query and we don't complete in 10 minutes, Velociraptor will cancel it. And that is super important when you, for example, have something like a big glob, for example, that goes through and searches the file system, and then you accidentally go onto a network file system, let's say, that's mounted, and then it becomes really slow because it's starting to scan, like the file server or something that's clearly not intended. And, you don't want to, just kind of use up too many resources there. So it basically times out. You can change this if you want it as well. And then this one is the maximum number of rows. So sometimes it happens that, this happened when you have the MFT parser, we talked about yesterday, no, the day before yesterday, where we parse the MFT, and we're supposed to filter it, right? Usually the MFT returns like 300,000 or 400,000 rows, right? But sometimes the MFT can be much bigger than that, by accident, and suddenly it's returning millions and millions of rows by accident. So there is a limitation there of how many rows, and it just cancels once it reaches that limit. Yeah, and then finally, there's a transfer limitation. So, and this is what I wanted to show you here. So when we're doing this CAPE collection, you see it's transferred 1.3 gigs. Right, and then if we copy that again, and this time we just change the resources, and let's say 100 megabytes. So we made a limitation of, let's say, 100 megabytes. Then we'll try and run it again. Then you'll see that it should cancel once it hits that limitations. Are the limits per client or total? So it's per collection, so yeah, it's per collection. So if we're doing a hunt, it will apply on each collection. I'm not sure if there's no limitation on the whole hunt, right? There's just per client limitations. But it's a good question, right? We might want to think about, changing it to a per hunt limitation. I don't know. And then you can see that it's reached an error, and as soon as it reached the upload limit, it canceled. It went a little bit over. I think it's 105 megabytes because it's just getting a full file, right? If it's half a file, then it will still finish the file, but then it will cancel. So this is the active cancellations happening from the server. This is something I don't know if I've actually mentioned it as well. Like if I just run this again, so this is a really big collection, right? And it's going to take some time to do it. And one of the things that I don't think mentioned with Velociraptor is you can stop any of the collections at any time. So there's something called active cancellation. So I can hit the stop button and it will immediately stop that, right? So sometimes it happens that you accidentally do something like a CAPE collection, and you can see that data coming and going, oh my God, there's way too much data, I don't need it. You can just cancel it immediately, and it sends a cancellation message to the endpoint and immediately cancels it, right? So this is important to make sure it's stability, for stability. Question, is it preferred to download collected files from the Velociraptor GUI or copy directly from the file system? I don't think it matters. Usually we prefer not to have people have access to the file system just from a security point of view. So, people shouldn't really have SSH access to the server as much as possible, unless they are super admins. So, if you give people like a reader level access, we talked about ACLs previously, then they can just, then I can just create a download and then download it, even with reader level access. But if you are, if you want to copy it via SSH from the file system, then you need to have, SSH access. So it's much more, higher level of access. And we don't really keep the original file stamps in the zip file anyway. So the original timestamps are in the results. With these ones are canceled, so we don't actually have them. But this is the results of the flow, because remember that everything is just the query. So the query returns rows, and then the rows actually contain the the information, the metadata, and the files are just kind of the bulk data that's collected, right? So so those files, we can tell when we receive them, but we don't keep their metadata timestamps in here. Okay, cool. So that's the Cape files collector. Okay, there's a question: how do we perform VQL query on Cape files we collected? So I mean, if you collected them from the UI, it's just a query like anything else, right? So you can click the notebook, and then you're back in here, and I can say where let's say source file matches EVTX, right? So I can put I can filter them and then do all the usual thing. But but once we do it, so I mean, we can still do post-processing, but I mean, the whole thing, the Cape files is just giving us data, right? It's I think you can also so there is an uploads plugin, and if we have a look at the help, it says retrieve information about a flow's uploads. So with the Cape file specifically, then this plugin, it just tells you about the files, the uploads that it uploaded, right? So then if you wanted to like copy a small subset of the files, you can do that with this thing, and then parse them, and other things like that. So we could do VFS path EVTX, for example. Just look at the EVTX files, and then you can still do parsing in here, right? But yeah, I mean, yeah, you can do that, but it's a little bit more clumsy, I guess. Select for each of those, right? Right, and then we can simply select star from parse EVTX. It's just a file, right, on the disk. So at the end of the day, file name equals. But this is the VFS path. So file store. So this file store function converts the VFS into a full file system path, so we can actually open it. So we just need to do that, path equals VFS path, right? And then let me just limit it a little bit. So it should then go and open. See, so it's just opening the event, the event files. So this is kind of like how you do. So you can do sort of post processing, and then you can do the parsing on the server. You see, but it's kind of clumsy, right? But you can still do it, right? Through this. So you just look at the uploads, find the EVTX files, and then apply, parse EVTX on it on the server to sort of process. So what's the best way to do it again? So yeah, for EVTX, the best way is to just parse it on the endpoint, right? So don't collect the Cape files, collect the parse EVTX, the EVTX Hunter or one of the other plugins, right? That's the best way. Just parse them directly on the endpoint. I mean, we discussed already why, you know, this is better because the message in this case, it's able to resolve the message because we are on Windows. It's actually resolving it from the local system. But if we were on a Linux system, that would not work. So you won't be able to get a message from it at all, right? And you know, so that's a lot less information. But this is just an example of how you can still process the files that Capefiles targets brings on the server, but you can see that it's just not very scalable because it means that, you know, the server is doing a lot of the work now instead of the endpoints. So you can't, you know, it's just a little bit more kind of annoying to do that, and it's not very scalable. But anyway, Capefiles is just all about bringing in the it's just all about bringing in the data, the files. Okay, cool. So yeah, so I've showed you that. So we've, you know, limited the resource limit, and then you can see that it canceled the collection. Can we still inject collected EVTX files to scene for processing? Sure. I mean, they're just files, right? So once they arrive, you can, if you just choose to use Capefiles to bring the files themselves, then you can do whatever you want with them, right? You can parse them, you can do whatever you want. I'll show you how to do this post-processing on the server, I think in module 7, so tomorrow. But you know, there's examples of this, like for example, there is this backup. This is an example of an S3 backup query that essentially, as soon as any Cape, so for Cape, this is specifically written for Cape, right? But it can be done for anything really. As soon as Capefiles collection is finished, then those files that you collect, because they're quite large, right? So you don't want to have them sitting on the server for too long. So it just creates a zip file and then it uploads it to a bucket, S3 bucket, right? So we've got upload to S3, we give it credentials and it pushes it up there. So this is an example of like a post-processing thing that you can do to kind of handle the results of flows. As soon as the flow is complete or collection is complete, then it processes it and does something with it. Like in this case, it just pushes it to S3, and later on today we'll see, you know, pushing it to Elastic, you know, these kind of things. Yeah, exactly. This is what they wrote, right? Yeah, exactly. The Recon InfoSec people wrote this one. So this is an example of that use. Yeah. Will you have this also for GCP bucket? So we don't have this specific one for GCP bucket, but it's just a matter of changing the upload to S3 to upload GCP. So if you use GCP, we could change that, and if you want to contribute that back, that's fine too. It makes sense, right? Yeah. Okay. Because it's just very easy. You just change the upload S3 to upload GCP and just give it different kinds of credentials and off we go. There's nothing really especially complicated about these things, right? They're pretty straightforward. Okay. Okay. So let's look at the offline mode of collection. So I've just shown you how to do collect files using client server. So we just have client server and we just collect a whole bunch of files, which is great. And let's go back to our original offline collection mode. And you know, in this scenario, again, we don't have Velociraptor installed on the endpoint, so we can't really talk to it. Or the endpoint is inaccessible because there is some firewalls or there is some kind of networking issue. We can't really use a server or whatever. Sometimes, you know, organizations don't want to have another agent installed, or they don't want to provide access, you know, egress network access or whatever. Right? There's a bunch of reasons why we can't sometimes install it. So it doesn't really need a server. All we want to do is really just collect these VQL, execute the VQL queries, right? And then collect the results. And instead of sending them over the network to the server, all we're going to do is we're going to write them to a file as a zip file, right? And then we'll just, get the zip file. That's really all it is. So in order to do this, what we're going to do is create an offline collector. So we call it an offline collector. So the way this offline collector is implemented, it's actually implemented in VQL. So that means the function to create the collector is written in VQL. So we're going to need to run a VQL artifact, because again, all VQL is encapsulated in artifacts on the server. So it's a server artifact. So you got to go into this server artifacts thing here. So it is just a normal server artifact, but it's a little bit more complex, and I wanted to have a slightly different UI for it than the normal UI. So it actually has a special UI, but the UI itself just runs a normal artifact. So there's nothing really magical about it. It's just a little bit of a GUI thing to help us build the collector. And again, by building a collector, all it's doing is it's taking just a normal Velociraptor binary, right? And then it's essentially embedding a configuration file in that binary that tells the binary what to do when it runs. And it says, I want you to collect all of these things, right? These artifacts and do these things, and then it does it, right? So it doesn't, but otherwise it's just exactly the same as it is a Velociraptor, right? Just a normal one, pre-programmed one. So this is the icon, right? We click on this. This is the offline collector GUI, and you can see a very familiar, interface. So it looks the same as all the other ones. And so, for these ones, we're going to choose again the cape file target, and then we'll go to the next thing along. And in this case, we'll do the basic collection again. So same thing. Okay. And now we're going to configure the collection. Now this screen is now how to build this offline collector. So the first thing is, the operating system that we want to build. And this basically means the version of Velociraptor that will be incorporated into the offline collector. You can put a password on the zip file that it makes if you want. These are the types of collectors. So this is the simplest one, just makes a zip file. So it's going to go ahead and just put all the files and and the results of the artifacts that we want into a zip file, and it's just going to leave it there. And then we as an alternative, we can push it to S3 or AWS or GCP if we need to. This is a tool. So we use something called a tool, which we'll talk about a little bit later on. But this allows us to configure where we're going to get this client binary, the Velociraptor Windows binary from. If you don't do anything, it will just download it from GitHub by default, right? But so basically the defaults are generally fine, right? So when we launch it, we have a quick question. Can we import offline zip collected into the main Velo server? Yep. So we're just getting to that. Good question. Yep. So we're going to get to that in a few more slides. Okay, cool. So what it's doing now is the first time it downloads the Velociraptor binary from the GitHub in order to build. So it uses that, and then it's going to repack it with a built-in config, right? So if you look at, so it's just a normal artifact, right, that runs. You can look at the log file to see what it's doing. This is the query log of the VQL code that's running. And, it's telling you, okay, I'm going to get it from, this is what I want. This is the binary that I need because it's a Windows binary. And I'm going to fetch it. This is the hash. I'm going to copy it. And then, and then it goes ahead and package and builds like a package, which is like a configuration file, basically, that includes all the things that we want for it to collect. And then it embeds it essentially, and then it uploads it. So when we go to the uploads file tab, it's as though it uploaded itself. This binary here is the collector right? So it's actually the pre-configured binary. So let me just go to, no, not this one, this is the elk one. Let me try another, open another command prompt. There we go. Okay. Users mic download. All right, so here, I mean, it just has all the files that I've got from before, but let me just download it. So I'm just going to click on that, and that will download the binary into the downloads directory from the server. Okay, so this is the collector. So this is the one that was prepared, right? So when I run it, it's just Velociraptor, but it's already, if I just run it without any arguments, command line arguments, then it knows what it's going to do, right? So it's just going to go ahead and collect that cape files, targets ones that I, chose. It's now running the artifacts that we selected before. So it already knows what it's doing, right? So if it's collecting the files, that's going to take, it takes the same amount of time, but it's just putting it in a zip file, right? So so it's collecting that, it has some the recycling bin and other things like that. So yeah, so it's just part of that cape thing, and then it will put it into a zip file, and that's basically the result. But the other thing, so I've just shown cape files, but it's really just any artifact, right? Including, PS list, process dump, everything that we've done, you can do in this way because it's just a VQL collection. Yeah, so still with VSS and row read support, so everything is exactly the same. It's just doing it into a zip file instead of into a server. This binary runs on the fly. Doesn't install a service or anything. No, so it doesn't install anything. It just runs as it is, right? It does actually write some temporary files, temp files, and this is why we can specify the location of the temp files. Yeah, and once it's complete, will it leave traces on a system? So it's hard to say, right? You're still going to have things like prefetch and, you're still interacting with the live system. So it's very hard not to leave traces on a system, but you're going to have evidence of execution that you've just executed this thing, right? So it's going to leave some traces, right? You can't really get away from that in a live response type scenario, right? But it minimizes its, well, it doesn't have to be, because the thing is that you can actually run arbitrary VQL. So you can change the system if you wanted to. So you can actually implement remediation this way using Velociraptor as well if you needed to. Okay, so it's going to take a couple of seconds, and then it will just make a zip file. So you see it's doing the logs now, the EVTX logs. They're just zipping them up, and that sort of thing. Now again, the same thing is happening here as when we're doing normally. When we collect the registry hives, every time that a file is locked, then Velociraptor will switch to a NTFS parser and extract that file anyway. Yeah, can this push the output to S3 instead of zip? Yep. So this is that option that we had, here. We chose our cape files targets, and when we choose here, AWS bucket, and then we have to put all the credentials, for AWS. And what that's going to do is it's going to build that zip file and then just upload it to this bucket, what we tell it, right? So, and we can put password and other things in there. Cool. So that's a great question. Oops. Okay. So then when it's finished, right, then it's gonna have a zip file there. That's the zip file. Which contains, everything in it. So see, it's 150 megs. It's compressed, right? So it's a little bit. It's going to be the same 1.3 gigs, but compressed. And that's it. It just leaves that here. So now, if you want to upload it, then S3 is probably the best option here. Because then, but then in order to do that, you have to have egress as well, right? It depends if that makes sense for your situation. All right, so let's just recap. So we created that offline. We went the offline collector. We went through the GUI. We can select these kind of output types, and it creates a special. Once we do that, the server will create a special executable that we can just download from the GUI, and then we run it. It does its thing, and off we go. So if you're just if you're interested, so it is actually a normal Velociraptor binary, right? So if you run it without arguments, it does the collection, right? But it's just a normal binary. So if you give it arguments like help, then you can see it's just a normal Velociraptor binary. And you can do this config show. It's just got an embedded configuration file. The configuration file is embedded inside the binary, right? And so you can just show it and you can see what it's created, right? So this is the configuration that is embedded in the binary that makes it do what it needs to do, right? So you can see that, it's got an auto exec part that it automatically runs by itself without argument. When you run it without arguments, it requires admin, so it will refuse to run if it's not admin. And then you've basically got this is the log file that it's going to write, and then you can see that it creates an artifact itself that calls this Windows K files targets with these parameters, right? So we are choosing the basic collection to collect, right? If we wanted to choose more, then it will have different thing here. And then off it goes. This is actually just a VQL that makes it all kind of happen, right? And so this is really what's in the binary. That's all it is. All right, let me show you. Oh, so you can actually select a report. If you choose a report, then it will build like a HTML report. But I never really kind of use that. It's more like for eye candy. It's just kind of so there's certain uses for it, I guess. But yeah, I mean, I don't really use it much. This is why the default is the report is not selected. So let me just show you another example. Auto runs. Now this is an artifact which uses the Windows the sysinternals auto runs tool. So you guys already know the sysinternals is what's owned by Microsoft now. So it's like a bunch of these utilities that are really super useful. Probably one of the most useful utilities of sysinternals is auto runs, and that is a tool that goes through and finds all kinds of persistence mechanisms that are commonly used by malware, and it's kept up to date as well. So it's got really good coverage, and it's quite a good tool. So we can try and replicate what it's doing, or we could just say we just use the auto runs by itself. So I'm just going to show you this artifact, and this artifact actually incorporates the actual auto runs tool, but it brings it with it. So I'm just going to show you how this offline collector works. As a user, you just select auto runs as what you want to collect. This is the artifact that we want to collect. We can configure it as normal here, and we can create. Let's just create a report. So I'll show you that, and then launch it. And the same thing is going to happen as it did before, right? We're going to create a new collector, but this time Velociraptor already knows that it needs to also package the auto runs binary in the actual binary because one of the artifacts needs it, right? So So it already takes care of the dependencies and make sure that, oh no, not this one. Make sure that we have all the things that we need to execute that collector. So this second collector is the one with the one here. So you can see that when we run this one is going to look for the auto runs. Then you can see that it's getting these tools in there, the auto run tool, and then it actually copies it into a temp file. So it extracts that auto runs tool, and then it launches it, right, with the right, flags and so on. And then it's going to capture the output of the auto runs, put it in the zip file, this sort of stuff. But so this artifact, the auto runs artifact, is an example of an artifact that uses external tools. We're going to talk about that tomorrow. But in this context, I just wanted to show you that the offline collector will include that any kind of third-party tools that we might need into the collector, so we don't have to worry about it too much. Okay, cool. And this time we ask to create the report. So we have a report. You can just open it from Chrome. So you can just open that report. It's just a HTML file that's created. It's the downloads. Okay, and you can see that it basically has the output of the top 100, the first 100 rows of each artifact, and it's possible to also control the output of this report in a more specific way. So let's talk about that. So that's the report. Let me continue down here. Okay, and then there's a whole bunch of skip slides here to do with exactly how that works. So you can have a look at it. You can also use the AWS. There are some slides here you should read about creating the S3 bucket user. So you don't. So you can create a bucket that has only write access, and you can't really read from it. That's important because you are uploading when you want to upload to S3, those credentials are embedded in the binary as well, right? Because the binary has to be able to be fully automated, so it does its own thing, right? So those credentials you have to lock them down, so you can't use them to then go ahead and just download all your files from your bucket. So these slides here, which are skipped, but it's just go over them to make sure that you are creating the correct bucket policy to make sure that that you're not accidentally doing this. There's a question: is it easy to use Azure container? I actually don't know, because do Azure have like an S3 compatible mechanism? I know that there's a lot of open source bucket kind of applications that use the S3 protocol, and for those you actually can you have to specify, like in any of these, you can specify a different endpoint here. So this there are many other services that use S3, so they have similar I guess protocol to S3. So all of these things are the same, except they obviously have a different endpoint. So you can specify this. I'm not sure how Azure does it. In Azure, it's easy to set up SFTP, and Velociraptor should be able to send data to SFTP. Yeah, that's right. So you can choose SFTP as well as another mechanism. Yeah. So there's lots of mechanisms here, but again, if you have another need, we can tweak this. Cool. There is a link in there in the chat for everyone. Okay, cool. Where can you see how much disk space an artifact collection is consuming on the server? Okay, so on the server, when you how much it's actually consuming, it's consuming the majority of the consumption on the server for each artifact, for each collection, is the uploaded bytes, because the rest is just generally JSON files, and they're not that big. So we don't really track the size of the JSON files, but we track the size of the upload. So Cape files collector is usually the biggest, offender. So you can say that it's approximately, this much space this collection is using up. You can actually delete them. So you can go over here, and there is this it's supposed to be an eraser icon, and that will delete the collection and recover the disk space. And it tells you here how much disk space you're going to free up. But again, this is just to do with the upload size, right? So it just adds it up, which is the same as here. And then you can just delete it, right? So it goes off and removes it. And you will see that essentially what it does is it runs an artifact here called delete flow to actually do that. So you can automate all that stuff. Okay, let me just, we have to hurry up a little bit. Okay, collecting evidence across the network. So when you don't have any, a Velociraptor in a client server, then you can use that. You can use another EDR solution to collect that. Usually, other EDR solutions, they have a mechanism to just run a file, right? And so you can upload the file, and that helps. So you can just essentially create the collector, the offline collector, and then you can just either push it out with another EDR solution, or you can put it on, a public share, so a read-only share, and then just run it across the network. I have a picture here of, I'm not going to show it, but this is an example of just essentially using a share, and we copy the Velociraptor thing to the share, and then we use WMI to call across the network and run the binary across. So it's like lateral movement basically, but we're using this for good. So it's the same thing that we've seen before with Win32 process create, and we're just doing it to call the collector to run the collector. And if we do this at large enough scale, then you can get sort of something similar to a hunt. Yeah, especially if they are all uploading to a cloud bucket, but it's still cumbersome, but it's sort of the best you can do if you don't have a client server set up. And then, then you end up on the S3 bucket, you end up with the file. Okay, now we're going to talk about importing the artifact. And of course, some of you have already kind of talked about that as a possibility. And importing the artifact is cool because it allows us to essentially bring the result of that zip file back into the UI. Yeah, so let me just quickly show that. Okay. Oh, so sorry. So this is about importing third-party artifacts. So not yet. I've got my order confused. Okay, this is about importing the actual artifacts from a third party. So you guys have yeah, doesn't matter. So you guys have written a lot of VQL in this course, and you're probably gonna go ahead and write different artifacts to detect the things that you care about. And you might want to actually share those with the community. And of course, we would love to have these artifacts, in upstream as well, if they're widely useful. But sometimes, they might not be widely useful for everybody, but still useful to some people. So it actually makes sense to have a mechanism that allows people to just kind of maintain their own GitHub with their own VQL artifacts, so that people can share that and they can build a community around it. And so there is a mechanism that allows us to just import a whole bunch of artifacts from another third-party source into Velociraptor. And it's very, very easy to do. It's really just designed exactly for this purpose, right? So because we're an open source, we want to actually support this kind of community of artifacts. So here's an example of one contributor. CCX Labs is an example of an external artifact provider. So I'm just going to quickly show you GitHub CCX Labs, and this project is specifically supported by another company, CyberCX, and they actually published a whole bunch of artifacts that are specifically designed to hunt for a specific type of malware and these kind of things. So these are specifically, you see, there's artifacts here with reporting and they have some Yara SIGs and other things, right? So they are kind of maintaining these artifacts, but they would like to share them with everyone else. So we can just import all of these artifacts at once into Velociraptor. So how we do this is we simply go to the GitHub and we just download the entire repository. And that's just going to basically bring in a zip file of the entire repository. Now in Velociraptor, we can simply go to the view artifact screen here. And there's this button here, which allows us to import, upload an artifact pack. So the artifact pack is nothing but a zip file that just has some YAML files in it, right? So that's really all it is. So we just essentially select that master download from the GitHub, and that's it. We just select that, click in the upload, and all of their artifacts are imported into Velociraptor at once, right? So if we do that, then it allows us, so you can see, you can see all of their artifacts right there. And so it allows us to kind of build, if you like, little communities of VQL artifacts that, do a particular thing, and in this case, this CCX digger is, it's specifically designed to just hunt for, a special kind of, a specific attack, right? So you can see that it imports all of these immediately as a pack, basically, and then we can select them. And you can go to their website and download the actual binary, and you can see that it goes through and does all these searches, and they even have a particular report that's created. So you can actually also create a different report. This report is specifically designed for essentially helping people. So it does a lot of the analysis and post-processing in the offline collector itself. So they don't really need to use a server to do the post-processing. It's not, there's a question, is CyberCX Digger something only Australian government are licensed to use? It's not a licensing thing, right? Because it's all open source. It's not really so anyone can use it, right? It's just, it's just they are specifically addressing, Australian government needs, but anyone can use it, really. Yeah, but anyway, the reason I'm showing you guys this is just to show you, if you walk away from this course thinking, hey, I've got this really cool idea about maintaining a particular set of artifacts to look for specific things or implement a specific thing, or maybe a particular process or something like that, then you can go ahead and work on your own project, and then have people kind of use that. So we can just import it from that. Okay, this is what I was thinking. The next thing is importing the collection into the GUI, and we've already sort of alluded to that. And we had a couple of zip files that we wanted to import into a GUI. So ideally, we want to take these zip files that we've created. Yeah. So any of these are collections. Like I said, this one is a bigger one, and I want to bring that into the UI. Now, this is just a zip file, right? And usually Velociraptor is not really installed on this endpoint, so there isn't really a client ID associated with it. So there's not really any place in the UI normally to put it. So what we can do is we can run a particular server-side artifact. So it's, again, server-side VQL, search for import, and there is an import collection artifact. Now, this collection basically allows us, this artifact allows us to import a zip file. Now, you can see that we have to give it a client ID or a host name because it needs to automatically create a client ID if it needs to. So for the host name, we need to somehow search for it, be able to search for this client. So we're going to create like a new client for this, because remember, it's an offline collector. So we have no idea where it actually collected. So this is the part where we actually say, oh, well, actually, you know, it was Mike's machine, right? Mike's machine. This can be anything really. And then what we're going to do is we're going to store the path to the zip file in here. So in this case, so this has to be on the server, because you can imagine you have like, you know, a 2 gig file. You're not going to be able to upload it from the UI, right? So you have to somehow transfer this file from the server, and then the server itself has to be able to find it somewhere. So this is, you know, I guess you still need to use Secure Shell for that, but to copy it there, you know, in reality. But here, this is the full path to the zip file, you know, on the server. And when I run this artifact, then it's going to run on the server itself, and then the server will try and open this zip file and import. It creates a new client, imports it, and so forth. You can see the log file of what it's doing. It's importing it, creating a new client, and then it's just basically, you know, importing all the files that are in it. So it's going to take, you know, a little while. And then once we do that, then it will create a whole new client that so it sort of emulates what you know, what that offline client is doing, right? It's like that offline client is an actual client that we're talking to. So the goal of this process is, in the end, it's just to sort of look like it's actually importing it, you know, and we can do all the post-processing and these kind of things. It's going to take a couple of minutes, I guess, to do. Yeah. And so if I search for it, now I can see that I have a new client here, right? Mike's machine. And when I look at it in the host information, it's not a real client. It's got a client ID, so we can, you know, address it and things like that. But it just says that the agent name is offline Velociraptor. We don't actually have like a proper agent on it, and we haven't never seen it, and it's red, so we can't even talk to it because it's offline, right? So it's basically looks like a machine on the system, but it does have a collection imported. So this is the collection that, you know, we imported, and at this point, this looks exactly the same as if it was a client server. So, you know, you can do everything is the same thing, and we can go to the notebook and you know, do the post processing as normal, right? So this is how you would import all your collection from the zip file into Velociraptor. Okay, so yeah, so the idea here is that we just, you know, we just use it as if it was, you know, moved by SneakerNet. Normally, when we do these collections, we use we try and collect as much as possible. So we will collect the entire MFT, for example, just because when we do offline collection, we can't really go back a lot, you know. So we try and get as much data as we can, and it's just off the one system, so it's not too bad. So we collect the entire MFT, and then so you can do this exercise later. You can just do this post-processing and do the MFT post-processing as we did, you know, before in the last session. Okay, so we went through that. I just point out the offline Velociraptor, and yeah, so that's the end of this module. We're a little bit over time. Yeah, but you can sort of do some networking using Windows RPC, so you can sort of emulate like a proper Velociraptor client server architecture, but usually it's difficult because they have to be on the same LAN. And like if one person is working from home, then unless you have VPN access, you can't actually launch that unless you have an EDR or some other mechanism, right? The biggest problem with offline Collector is that we don't really get a feedback of what's going on. And so we can't really pivot very quickly. So we can't do things like look at the prefetch files and identify some binaries that we are interested in, and then go back and look at them and collect more data, and then analyze things. So we have to be a lot more systematic with offline Collector. We have to have all of the artifacts that we want to collect known in advance, so we can schedule them, right? Because it's usually much more difficult to go back for a second collection. All right. So any questions about offline Collector? No. Okay. Cool. So we'll just get on to the hunting module, and I actually want to leave a little bit of time for the Elastic demonstration, because a lot of people are interested in that. So I might just skip a little bit towards the front of this module. So we've already kind of covered a little bit of this before, but this module is really all about trying to kind of practice what we've learned so far. So we've learned about how to write VQL and how to apply it. And this is more about the process of the overall process of how to create a hunting sort of mindset. And so typically when we start off, we have some kind of an idea that we come up with. Either we read a blog post or article, or maybe we do our own research, and we kind of come up with a new idea of a new kind of detection that we might want to do. So then we can explore the VQL in a notebook. Again, if we're developing a detection for Windows, we just run a Windows server with Velociraptor GUI, go into the notebook, start to play around, get our VQL working well, and then once we get a VQL that works well, we convert it to an artifact. Then we go hunting, and then we do some post-processing and try and understand whether our network was vulnerable or had detected this new thing. So we can sort of pivot from that backwards and forwards. The attack framework, is kind of a really good resource here. And you can spend hours just looking at the attack framework and saying, do we have good coverage on these kind of methods? Or it's just a systematic way of essentially of classifying adversary techniques, TTPs. But the attack framework itself is not super useful. It's useful, but it's not. It's useful for thinking about it, but what you really want to do is you need to kind of be able to recreate a lot of these attacks. And there's not a lot of information in just pure attack framework to help you recreate these attacks. So there is actually another project that I like to use called Atomic Red Team. Atomic Red Team is, we can search for it. Atomic Red Team. It is actually a GitHub project by Red Canary. And what they're doing there is that they're creating a whole bunch of these tests, these very particular tests for coverage on attack framework. So if you look at the Atomics directory here, there's a whole bunch of different tests, and they're very small tests that you can run that would trigger a particular kind of attack. And then you can use your own VQL to try and detect it. So for example, like this is the logon script, and it shows you how to actually create a logon script, and then you can ask yourself, well, how do I detect this? So, usually you would use that as the basis to start off some development of VQL, and say, how do I detect this, and then write an artifact and then detect it. So that's how you kind of go through the hunting process. So I've got a couple of examples today about how to hunt, but they're just examples that are more or less randomly chosen. So they're only not exhaustive at all, just the tip of the iceberg in a sense. So the first thing that I wanted to show you as an example is this image file execution option. And you can look at the MITRE attack framework and see what it does. And you can see that you can read it, and it essentially enables the developer to attach a debugger to an application. And then when you run a process, or a process is created, the debugger is going to be prepended to the application's name and then launched a new process under the debugger. Well, that sounds kind of interesting. So let's have a play and see exactly how it works. So normally we start off, no, not this one, this one. So we start off with Notepad, right? If I run Notepad, then you can see this is our favorite editor, right? So what we're going to do is we're going to copy and paste this this registry key. So it's a reged command. So just paste this thing, copy, and we just paste it, right? And okay, so it just added some registry key somewhere. And now when we run Notepad, it actually starts up. You see, this is Notepad++. It's a different application, not Notepad. So we type Notepad and we actually got something completely different. And this actually works at any place. So even Notepad, even here, you see I'm trying to launch the blue one, and it would still launch the Notepad++, right? So it's pretty much anywhere that I'm trying to run Notepad, it will still launch Notepad++. So it's like we're just like hooking the application, right? Essentially, this setting is a very good way of doing persistence. Imagine you can create a wrapper around Word. Every time an attacker runs Word, or the victim runs Word or Chrome, they'll get attacker control scripts, right? So they'll just get, it's like a way of hooking. So that's a pretty cool technique, actually. So how does it work? So there is this registry key, right? Image, Microsoft Windows NT, current version, etc. So let's get to the registry editor. Right, and we can have a look, HKey local machine, software, Microsoft Windows, NT, current version, yep. And then we have the image file execution options, right? So this key, it has a bunch of different keys underneath it, and you can see there's all these programs. And now we have this Notepad here, and there is a debugger value in here. So that value here, that's what does it, right? That debugger value says run this command in front of the other command. So whenever you run Notepad, you get this thing is going to run instead of it, right? So that's our persistence hook, right? So that's cool. Let's try and think about how we're going to detect this. So we're going to come up with a okay, this is the thing that we did the other day. And we've sort of done something very similar to that. So we've got HKey local machine. This is the key, right? So select star from, it's just a globe. And right, it's going to be HKey local machine, notepad, but debugger, right? And the accessor is going to be registry, right? So it's a similar sort of thing that we've done this before. So now we can see there's a data column, data.value. This is the actual program that will be run, right? And then you can see there's a lot of other types of things, right? There's mitigation options and other things, but they're not really very interesting, right? All we really care about is the debugger one. So the notepad.exe, that's our example, but we actually care about all binaries that are there. So we'll do a star, right? And okay, and then the thing that we want to know about is when did it happen? So we can we want to know the modification time, so mod time, right? And then what else is interesting? Then we have the full path. So full path. So that's the full path to the value. And in the registry, you really only have one timestamp. There's not really four, so they're all the same anyway. So and that's the timestamp that the key was modified. The timestamps are only on keys in the registry, so values don't have a timestamp. So so that is the modification time of the key when the last any of the values were changed inside of the key, which could be useful for to tell us when this thing was installed. You see, it's and this data.value is the thing that's going to run. Oops, data value as command. So that's the command line that will run, right? And then so the rest of it is not super interesting, so it's probably fine. And so immediately we've got this kind of thing, right? Now what we want to do is we want to just extract this binary, this name of the binary over here. So we can simply use dir name, right? Then that should give us this part, which is the directory part, all of it. Right? So if we do that, that just gives us this. But we actually just want the last part, which is the base name of that. So base name, that's this part of the path here, notepad.exe. And let's rename that column as hooked. That's the hooked binary, let's say. So now we have an artifact, basically. So this will detect it, right? So we have the modification time when it was last modified. Then we have the name of the binary that was that would be hooked, notepad, and this is what's going to run, right? So this is kind of cool. Let's create an artifact from that. So we just copy it, create an artifact. Oh, sorry, here, this one. New artifact. Let's say Windows.debugger image execution. What was it called? Yeah, so there is image file execution options. So I don't know, we'll just make a name. So, and then we just go in here, paste it, tab it a little bit. It's going to be a Windows only artifact, and client is fine. We just collect it, and that's about it, right? So, and then we probably don't need a parameter. So that seems good. Save it. Okay. And now we can create a hunt. So our hunt is going to be look for image file execution option. Right, select the artifact. So this is the one that we had, right? And we just launch it everywhere, right? So all of the machines that once we have to start it, okay, and then all the machines will then go ahead and search for it. And if any of these machines have a hit, right, then we already can see that this machine, this fully qualified, this machine name has that register that is hooked, and that is you know the hooked program. So I mean, you might say, okay, with Notepad, maybe it's okay. Notepad is probably fine, but you can then look and see whether there's anything more to suspect. But then that's kind of the idea, right? So we've got a detection now against this kind of vulnerability or this kind of attack. You can create whitelist of OK binaries and so on, and then just go wild, right? Digital signatures and all kinds of stuff. We've sort of explained this before. As an example, with the regex, you can pull out the name of this binary, which is the thing before the space, and then you could figure out whether that has a signature or hash or whatever. Yeah. So basically, we've seen how we can develop this kind of attack. Again, we walked through the process. This is the process that we talked about before, right? So we started off with an idea, wrote a VQL, and then developed an artifact, went hunting, and then we can do post-processing. Maybe we filter out as a post-processing. You're going to filter out the Notepad examples because they're probably fine. Okay, this next exercise is about dumping process memory. And we've kind of covered Yara signatures before, but this time we can apply them to process memory. So there's a whole bunch of malware that runs only in memory, attack tools that run just in memory. And so it's, we can't really detect them on disk. So we can do Yara sig in memory. So an example to this is Cobalt Strike. So Cobalt Strike is a very sophisticated, I guess, attack tool, and it's got a pretty malleable CNC on the network. So it's difficult to tell by network forensics exactly whether the beacons are Cobalt Strike beacons. And it doesn't always have a file presence, right? So sometimes it just injects into memory and we don't have any files. So, but it's actually pretty easy to detect it on the running system. So there is a project called Malpedia. So there's I'm just going to show you quickly, Malpedia, which this is just an example, right? But they are developing a bunch of signatures that are that can detect separate versions of the same family. So in the case of Cobalt Strike, you can see that what they actually offer. Just click on that. You see that they have a bunch of samples that they use, but all different versions. And then down the bottom, just as an example, all the way down the bottom now, they have some Yara rules that they make available. And these Yara rules are actually designed to match Cobalt Strike binary. You can see that they are automatically generated. These Yara rules are, automated, and they're looking for code sequences that are found in the binary. So it sort of makes sense, right? Like if you have something like Cobalt Strike, then you have a certain version. Then the next version, probably most of the code will be similar, right? It's going to be the same. you're not going to really rewrite it. So there's going to be a lot of common functions that are carried over from version to version. So if you just have a bunch of signatures that address the code sequences, then it's going to be very hard to change that, because each version is reusing most of the same code from the last version. So you're more likely to be able to pick a new version of this Cobalt Strike when it comes out. So it's a much better signature. So if we apply this to memory, then we're going to be in a better shape. So let me just close this. So the example that I have here is just a little exercise to show you how to do scan in memory and how to hunt for things in memory. So I've got a little notepad example. So we're going to start notepad. Now it's going to be notepad++, but that's okay. And then what I'm going to do is create a new file, and then just write this is a secret. And I'm not going to save it anywhere. So this string is only in the memory of this notepad process. Right, so I can just hunt for that specifically. So let me just search for it in memory. So I've got Windows detection process memory, scans process memory for signals, and we have a Yarrow rule. Okay, so let's have a look at a Yarrow rule. We can actually type a full Yarrow rule here. Yarrow is a little bit verbose, so you need to, you get used to it, but you have to go like, rule X strings. We went through that previously. $A equals this is a secret, right? And it's going to be ASCII wide, no case. Okay, and then condition any of them. Right, so that's our Yarrow rule. We're going to look for any processes that start with Notepad, and yeah, hopefully I didn't mess up my Yarrow rule. Oh, so this is the wrong client. That client is not going to answer because it's not really there. Actually, let me just copy that from the last one, so I don't have to type so much. So this is the rule, right? Okay. Anyway. Launch that. And let's see if I've messed up my, no. So it's going off and scanning all the process memory on this machine, right? And it's going to take some time, and it really depends on how many processes we're scanning. It can take quite a long time. And then hopefully it will return a hit. So you see it's already uploaded 94 megabytes. And if there is a hit, then it will take a memory dump of the process and then upload that. So this is what we're seeing here. The process is transferred, right? So we're sending one row because there was one hit, and we uploaded, this is the hit. We created a crash dump and then upload that. So this is the process that had that string in it. So this is an example of this artifact that you can write a Yarrow signature to scan memory. And then if there's any process that hits that, then it takes a crash dump and then it uploads it. Now this crash dump that it sends is not a full memory dump, right? It's only 127 megabytes, right? It's the process memory only. So it's sort of, if you've used volatility on full memory dumps, it's sort of the equivalent of proc dump. It's in fact, that's what we call it as well. And you can use, but you can use it in the Windows debugger because it is just it's a proper crash dump, right? It's a dump file. So you can just load it up in the Windows debugger properly, right? So it actually, loads it properly, and you can do anything you can do in a debugger. So it's just calling the API to create the crash dump. So it's not as big as like a full crash dump. It's just that process, but you can do all sorts of stuff with that, and hopefully, if it's a Cobalt Strike beacon, you might be able to extract the configuration from it, and then be able to go further, right? But this is sort of like an outline of the VQL. The VQL itself is pretty straightforward. We just we just do a process listing that allows us to narrow down only the processes that we are going to scan, and then we do a proc Yara, which allows us to apply the Yara signature on the processes. And then if we're getting any hit here, then we're going for each of those hits. We do a proc dump, so dump the process memory, and then upload it to the server. So another question: how many rules could you run at once? Is there a limitation? And how about resource utilization? So are you asking how many Yara rules you can run? So you can run a lot of Yara rules. Yara is really designed to run many, many rules. And all we're doing is we're just calling Yara. So I think Yara can actually run quite a lot of rules. Some of the rule files that we use are, several megabytes big. So they're pretty massive, right? With like hundreds of rules. So I think Yara is a pretty impressive tool there. Is there a way to detect name pipe? So a name pipe is just a handle. So you can use handles, and then you can detect name pipes that way. I think there was an example. I think there's an example in the blog post about that. How resource intensive is this Yara search against process memory? So this proc Yara that we are calling, so essentially Velociraptor doesn't really do a lot with it. We just call like the proper Yara library. It has the facility to scan process memory, and I believe it's pretty efficient. But again, we don't really have any overheads there. We're just really calling the library. I think it is pretty efficient though. I'm not sure if it stops the process while it's scanning it. It might. So I don't know how, if it's a critical process, maybe it has some issues there. I'm not sure. We are just calling the Yara library to do that in here. Another question. I find that when I run Yara hunts, the client error, and it says it's timed out. Okay, yeah. So again, the same resource limitations are taking place regardless of any query, right? So any query that you are running, we still have this 600-second timeout. So if we're going to do a big Yara scan that's going to take a long time, then it might even take longer than 10 minutes on the endpoint. So this is a problem, right? We need to know like what to do about it. Like, are we prepared to take longer than 10 minutes on the endpoint? And if we are, which we might, then we can go in here and just change the resources, and increase that number, to maybe an hour, right, or something like that. So whatever it is. Otherwise, once we exceed that 10 minutes, it will time out. So yeah, it's just a safety mechanism there. There we go. Let me just, I think I'm going to skip this WMI event binding because it's not maybe all that interesting. It's just the one with there is an us exercise here. I'll leave this, maybe I'll go back to it if I have time, but I really want to get to the post-processing a large hunt. The pool clients, yeah, we'll go back to that later. I think I really want to get to the part where we talk about the Elastic stuff. Oh, the parallelize plugin. So I think we talked about the parallelize one in module 2, but it is just a performance type thing. Okay, let's go and talk about. So this one I just really want to get to the elastic part, otherwise I'll run out of time. So let me I'll skip forward and then I'll skip back. Oh, okay, cool. So elastic, right? Okay, cool. So a lot of people are really interested in this elastic integration, and it's really great. And so, but as far as Velociraptor is concerned, we don't really do like all that much. And what we do is not terribly sophisticated, but it just happens that it works really well with people who are running Elastic or Splunk. And so it really fits really well with the rest of the tooling. So I just wanted to really kind of spend some time to discuss this, to talk about it. And also just give you an idea for the first time of how we can do post-processing, how we can automate some of these server, the way that the server works. So let's see how that works. So basically, I'm just going to show you how to use it if you want, and then we'll actually look at in detail how it works. So the first thing that I'm going to do is I've got this Elastic stack set up. So this is an Elastic server that I've got, and you can see that what I'm doing is I'm forwarding my ports to the Elastic server so that so that I can essentially, it's like a VPN basically, because I don't need to have any any TLS on the Elastic server there. So so I'm just forwarding my ports to my Elastic server and then using SSH tunneling. Now over here I've got Kibana, so that means I will be able to log localhost 9200 is, oh no, that's the Elastic port, sorry, 5601. That's the Kibana port. So it's just an Elastic server with Kibana, right? It's nothing really too impressive. And the way that Elastic works is that it has a REST API, so you can use curl to actually query it. So this particular query lists all the indices. So this is just to do with the Elastic API. You just kind of use curl, and it's got some kind of REST API. And so you can see these are all just the normal Kibana indexes that it works, but there's basically nothing else on this system, on this database. So all we have to do in Velociraptor is, if we want to forward events to Elastic, is we have to run what's called a server event artifact. So remember that we talked about event queries, and in event queries are always running. And whenever an event occurs, then we do something. So so this is what we want to do, is we want to have something running on the server all the time that watches for events to occur. Specifically, what we want to watch for is that particular flows or particular collections occur. And when the collections occur, we want to do something about it, right? And the something that we want to do about it in this case is we simply want to push the data to Elastic. That's all we want to do, right? So let's create, we just select some artifacts. Now, by default, we just collect monitor health, which is the same thing as the client telemetry. So we're just going to search for Elastic, oops. And there's two artifacts that deal with that. So let me just do this one. So this particular one, and you can see the code, the VQL, is basically watching for completions of events, and when they're complete, then it will upload them to Elastic. So if we select that guy, right, then we go over to the parameters, and we can configure it here. Now, if you have, different settings here for Elastic, you can, have an IP address here or whatever. Because I'm just doing SSH forwarding, then it's just going to be localhost because it's going to go through the tunnel to the remote server. And now over here, I can control which artifacts are going to be uploaded to Elastic. Like I don't have to upload all of them. But if I choose dot, then it's all of them, right? So wildcard. And sometimes people have these other settings here for Elastic. So which, we don't. So we're just going to launch it. And that's really all that's happening, right? So as soon as we select this artifact is now running, right? And so we can actually, so it's just running at the moment in the background. And you can actually look at the logs. So every time a query is running, it's telling you that it's running, right? So it's still generating logs to tell us it's running. But there's no output right now. So that's really all it is. Now, what's happening is the server is just sitting there watching for any collections that occur. So let's do some collections. So we'll go over to our active client and we're going to collect something. So what can we collect? I don't know. Let's collect PS list, right? So just a process listing. Because, why not? So we're going to go off and collect that thing. And what's happening is that this thing is just happening, right? Normally, it's going to collect that. It sends the result to the clients. The clients run the query. The clients return the query. And when that tick goes, when this goes from running to stop to finished, right? So it's completed. It took 10 seconds, right? So when this happens, the server receives an event that says, hey, this thing's finished. And then the server says, okay, cool. Let me just push all the data up to Elastic. So it just happens by itself. You don't have to do anything special. So it will just appear in Kibana. So if we just click in Kibana, then we should be able to see. So I've got here this is called a index pattern, right? And this is the data. So I can see the data is just appears in Elastic. I don't really have to do anything special. It just happens. And you can see that, let me just go back to the curl command. So I'm just going to look at the indexes and a new index is created. So the index that's created is artifact underscore and then the name of the artifact. And, it's changed to an index name. So, have underscores and things like that. And so each artifact is pushed to a different index in Kibana, in Elastic, right? And then, you can then just do whatever you can do in Kibana, right? Because they're just records. They just go into the Elastic stack and you can write, you can query it however you normally query it, right? But the Velociraptor side of it is that simple. That's all you do is you just, select this event and off we go. So it's not really that exciting, but it's actually pretty useful. It just happens automatically. And you can see that, we've just sent a whole bunch of items to Elastic. So this output here is just more about telling us, did it work? Did we manage to push the result? Was there an error? It's just a part of the, in the other thing. There was a question, is there a way to put data in other specific index? So you can do anything you want, right? Because it's all just done through VQL. Let's look at the Elastic query again. So if we look at the query itself, you can see that that all it's doing is it's simply watching for the artifact completion, and then it basically just builds up for each completion, right? Then it gets all the artifacts and then builds up a query here. Source we've seen that one before, right? It's just allows us to get at the data that was collected. So it just, all that source plugin does is it just reads the JSON files that are collected, right? And you can see that's the name of the index is created, as part of this. There is an underscore index column, and that tells it which index to put it in. And that's really all it is. Then it's just calling this Elastic Upload plugin that receives a query, which is an event query. So it just receives that query. So every time it's an event query, so it doesn't quit, it doesn't exit, right? It just keeps working. So every time something happens, it just pushes more rows, and then this thing will push it into the right index. So I think this one is actually ignored anyway because we have an index here. So yeah, so that's basically it. So the question is, can we put it in another index? You can do anything you want because you've got full control over the VQL. It's literally pretty straightforward. It just calls this API basically. Cool. So that's the Elastic things, and as I said, a lot of people use that very heavily, to do a lot of the post-processing even, and so on. So yeah, that's just a bit of a slide there about how to install it. And this is what we went through in this demonstration. We just showed you the artifacts that were created. So yeah, different ones. Like if I go over here and do an interrogate one, that runs generic client info artifact. So this one. And so now we should be able to see, actually, I'll show you the index. We should be able to see a new index created, generic client info. It has two ones, so it has all the users and it has the basic information. So you can then, the usual way is to just write these index patterns here, and then you can use that to fine tune the queries according to specific output of the artifact. Okay, cool. So so that's, yeah, you can delete the indexes and we can see this. All right, so that's the Elastic thing. Maybe we've got a few more minutes to cover one more. We'll just go back. Let me just quickly show you the pool client. So yeah, pool client. So we actually have a load testing tool that we use to load test the server. And I think it's a really good example of, it's a good learning tool as well. And it's called a pool client. So a pool client is a client that pretends to be many, many clients. And that's how we use that to load test the server. So at the moment, I'll just quickly show you how to use that. We are running Velociraptor GUI, so it actually just runs. It uses a temp directory as the place where it creates files, right? So temp directory is in app data local temp, and you can see in here that it created a server config and a client. There's also a client config up above, right? So these are the ones that we use for this deployment. So I can actually run another copy of Velociraptor. See users like downloads Velociraptor. And if I do --config clients, so that loads the client config, and then I tell it to just be a client. Then we'll go ahead and just start to be, a client, right? And talk to that server. But if I can similarly tell it to be a pool client. And when it's a pool client, I'll just do --help to show you the options. When it's a pool client, I can tell it how many clients to be, right? So it runs multiple clients, but this is only probably not as big machines, and we don't have too much time. So we're just going to tell it to be 10. And so you can see that it generates 10 keys, and then it just immediately logs in and starts enrolling. And what we're seeing here is all of these pool clients are enrolling. And if we go back to our machine, then now you can see that we are starting to see these 10 separate clients, right? And in just a minute, they'll be enrolled. So enrolling basically queries a host name. So and they basically appear as full-blown clients. So they're actually completely their own clients. So all of the hunts that we've got active right now, because they're active, you see they're immediately scheduled as soon as those clients started, came online, they got scheduled straight away. So so they've run these queries, right? But they're all the same. I mean, they're the same client, right? So basically, whatever we query, when it runs the VQL, it runs it on that system because it's all the same system, really. So we're going to get the same, the same results, right? But we're just going to, as far as the server is concerned, they're completely separate. So we can basically do load testing, with that. So, so for instance, if I created, a hunt, and in my hunt I said, I don't know, PS list, for example, and I'll look for a PS list, then what will happen is that it will run this PS list it will schedule it on all of these 10 clients, and it's scheduled immediately on 7 clients, and 11 there's 10 pool clients, and one is already there, and then basically they'll come through, and then I'll get all of my process listings will come in, right? So I'll get they'll all be the same for the 10 clients, and then if there's any other ones, that they'll be slightly different. So it's just duplicating the results 10 times. So yeah, so you can use that to get the feel of running a big hunt, and appreciate like what it feels like to run a big hunt and see how Velociraptor behaves at scale. And you can use that to just get an idea of how scale works. But again, we use it for testing only. So in this example, I wanted to show you how to post-process a hunt. So just real quick, we're going to collect Windows System Services, and actually, we've collected PS list, so we may as well work with that. So we've collected PS list now. So because it's a big hunt, there's actually quite a lot of rows in this hunt, right? Because if you look at these clients, each one is returning 184 rows, and I have 10 of them, but I could potentially have thousands of them, right? So what we could do, this is how we would post-process this hunt. So let's say that we only wanted to see the processes that were called Velociraptor. Then the hunt results plugin, it shows us the results from all the hunts, from all the clients in this hunt. So we can just limit it that way, right? So that would show us just the Velociraptor ones, right? And and then we could, they're all different processes, but then we can, maybe look at different executables. So we can go group by, executable, and that will show us only the unique executables or whatever, right? So we can do these kind of post-processing on the results of a hunt. This is a good exercise to just try and have lots of hunts. So you can set it up like as usually, I think when I test it, I usually use about 2,000 or 5,000 clients in the pool client, and then you can really sort of start to see like the effects of scale when you have 5,000 to 10,000 endpoints, and you can see how it scales up. Okay, cool. So I just wanted to quickly show you that that one, and there's a kind of an exercise here about how to run it. and how to do the stacking. So the stacking again is the group by. Cool. So is there any questions before we go? I think we'll probably skip. I think there's only like one topic that we skipped, so it's not too bad. Any questions? Cool. All right, so let me just hit the conclusion slides. Okay, so this one, in this module, we've covered hunting, and we looked at how the TTPs in an attack matrix can actually be used in order to try and kind of germinate these ideas for hunting and create new opportunities for developing VQL. So there's really two types of goals when you do hunting. The first one is to establish a baseline. So in when I do a hunt, I either try and establish a baseline to see what's normal. So this kind of hunts usually collect a lot of data, and then I do a lot of post-processing and and maybe like stacking and try and look at different kinds of data that come back from the hunt. That's the first type. The second type is a high-value detection. So once I actually refine what's normal, then I can look at writing a VQL artifact that doesn't return any rows until I actually have a positive hit. So an example of this was, the IFEO detection. So this is the hunt that we had, right? Look for IFEO. And in this particular case, if there isn't really a hook defined on the system, that artifact is not going to return anything. So I can do this artifact on thousands of machines, and it's not going to return anything. It's only returning a row for those machines that are in fact vulnerable. So this is what I would call like a high value detection. It's a high value detection because it's very specific. It's very surgical. So these are the two kind of goals when we do hunting. So I think it's important to kind of understand what it is that we're trying to achieve. Cool. So that's the sixth module, and then tomorrow we're going to have the last module, which is extending VQL, and that's kind of a big one as well. So I'm going to just turn the recording off now. Okay.